Question number 4. An experiment to test the effectiveness of regular treatments with fluoride varnish to reduce tooth decay involved 36 volunteers who had half their teeth. The right side or left side determined by a coin flipped, painted with a fluoride varnish every 6 months for 5 years. At the end of the treatments, the number of new cavities during that treatment period was compared to the treatment fluoride varnish side versus control, no fluoride varnish side. The appropriate statistical test for analyzing the results of this experiment is, well, we're talking about the number of new cavities. So a number that's going to be talking about means, not proportions. So this is going to be a T. And we're talking about the appropriate statistical test. So it's going to be a t-test, but since this is a right versus left side of the same person, this is the classic matched pairs. So it's going to be a paired t-test, So t-test, you can rule out the z's. And it's not a difference in means, it's paired data, matched pairs data. So it's going to be C. Number 5, an airline claims that its planes are on average less than 8 minutes late in landing. The appropriate hypotheses. Your null hypotheses will always be a mean parameter. So mu will be equal. So you never want to have not equals or less than or greater than. So that's ruled out. And you want your number not to be a sample, but in the actual null, the actual assumption here. So we're trying to prove that it's less than 8. So we don't want to say our null is 7 because our null should be that it is 8. And we're trying to prove that it's less than 8. So right there, less than 8 is what our alternative should be. Number 6. A tire manufacturer claims that it has developed a new all-season radial tire for passenger cars, excluding SUVs, which has a shorter skid distance than the known mean skid distance, 140 feet. So this is the parameter. This is our known. Mu is equal to 140. A consumer group wishes to test this claim. If mu represents the true mean skid distance for this new tire, which of the following states the null hypothesis and alternative hypothesis that the consumer group should test? Which has shorter. So we're trying to test to see, is it shorter? That's going to be, again, less than. So your alternative would have less than. So once again, our null will always be equal. So we can rule out A and B. And then our alternative wants to go in the direction it states. So in this case, less than, shorter, C. Another one, number 7, a South Florida newspaper reports that the average cost of renting a car in Florida during the months of January and February is $36 a day. The random sample was taken of 40 people who rented cars at Fort Lauderdale Airport, and the mean of the sample was found to be 34.2. To test this claim that the average rental in Fort Lauderdale is less than the reported by the newspaper, which the following statements can represent the null hypothesis. All right, the null, again, is the no difference. We're assuming that it is $36 per day, and we're going to test that it's less than that. So our null would be mu is equal to 36, always equal. An alternative would be mu is less than 36. And then this is our sample mean. So what we'll use that number when we're trying to calculate our p-value and test statistic and all that stuff. But right now our hypotheses are just going to be this, and that's asking for the null. Oh, again, it's going to be C. Mu is 36. Number 8, a hypothesis test for the null hypothesis mu HO mu equals 20 against the alternative hypothesis HA mu is not equal to 20 at a significance level of alpha. If the same procedure is used to test mu equals 20 against HA mu is greater than 20 with the same data, what's going to happen to the p-value? So the way that works is if it's a two-sided test, in this case, this is going to be a two-sided, then whatever our sample is, let's say, you got your null here is at 20. Let's say we get a sample of, I don't know, 25 or whatever. And we're testing, in the not equals case, both this side and this side. So on not equal side, we're testing both above the sample as extreme or more in this direction from that distance from it, as well as that distance from it on the other side. Now, what happens in a one-sided test, whether it's greater than or less than, is you're only testing that side on that direction of it. So what's going to happen is your p-value here, remember your p-value is the probability that it falls under these tails. The p-value in this case is these shaded areas combined. Now in this case here, your p-value is only going to be this shaded area. So your p-value is going to decrease. It's going to actually be half, p-value would be half as much going to one-sided. It'll double if you're going from a one-sided to a not equal, but if you're going from a not equal to a greater than in this case, it's gonna be cut in half. So that p-value will decrease. Number 9, a major tire manufacturer claims that his shock absorbers last for 5,000 miles. A consumer watchdog group claims that the actual mileage is lower. If mu represents the true average life of the shock absorbers, which of the following are the appropriate null and alternative hypotheses? So hopefully you guys are getting familiar with these here. This is null will always be, again, equals the true average life of shock absorbers is we're trying to test to see if that mileage is lower. So again, we're trying to test the claim that the mileage is lower, less than. And it's as simple as that. So we'll stop this video here at 9, and then I'll pick up on the next video with the next couple questions.